Hey there, my name is Alejandro, and welcome back for day 77 of me doing the Daily LeetCode Challenge after I reach 1 year's worth of green contributions here on GitHub. So today's problem is for October 1st, 2024, and let's get straight into it. Okay, today we get a LeetCode medium problem 1497. Okay, 1497, check if array pairs are divisible by k. Given an array of integers r of even length n and an integer k, we want to divide the array into exactly n divided by 2 pairs, okay, such that the sum of each pair is divisible by k. Okay, return true if you can find a way to do that, or false otherwise. Okay, let's look at an example. So here, okay, r equals 1, 2, 3, 4, 5, 10, 6, 7, 8, 9, and k equals 5. Okay, so output is true. Why? Pairs are 1, 9, 2, 8, 3, 7, 4, 6, and 5, 10. Okay, and it says, okay, we want to divide the array into, okay, n is even. We want to divide the array into exactly n over 2 pairs, okay, such that the sum of each pair is divisible by k. Okay, so 1 plus 9 is 10, is divisible by 5. Okay, 10, 10, 10, and 50. Okay, these are all divisible by 5. Okay, so here, okay, so the output is true again. Why? So like 1 and 6, yeah, that's to 7, or divisible by 7, 2 and 5, yep, okay. Okay, ooh, okay, I can already tell. All right, let's look at the constraints. Yeah. So okay, array length equals n. Okay, so the array length is up to 10 to the 5. So n squared solutions are definitely not tolerated. N log n solution is probably tolerated. So something we can definitely do is sort the list, which actually for this type of problem is probably going to be very, very useful. N is even. Yeah, the numbers are this. And k, okay, so k is up to this. Does that mean that k can be bigger than n? Oh yeah, it's just representing the values, right? So okay, no, not to worry. Which is also very interesting, right? So k is not up to something like 10 to the 9, which means that it might be relevant in terms of the. Okay, I don't want to get ahead of myself. Okay, first thing that comes to mind is this is one of those problems where I was like, okay, return true or false, which really makes me think of like not only my algorithms class, but it's like my computational complexity class, right? Where we're dealing with like NP hard problems, NP complete problems, where it's like return true, like for problems like subset sum or so on, or like return true if there exists a clique of size k or this and so on. Those like return true or false if a certain condition exists, where it's like oftentimes those problems are like NP hard and so on, and you can make a reduction. But in this case, like obviously it's on LeetCode and so on, so it's probably not going to be like an NP hard problem, which means that there's usually going to be some type of trick. Usually when like something is like of this kind of feel, and there's like usually some trick behind it and so on, you can oftentimes get away with something like dynamic programming. But here it's like I'm not already too sure, convinced of how we do something like that, right? Where it's like, yeah, like we're like if we do like up to here, right? It's like, or up to these elements. It doesn't mean like like 8 and 9 might not have a solution together, right? And so it's like they belong to some pair in here and so on, so it just kind of makes things complicated. So okay, I gotta think. There's probably so to these types of problems, usually there is like some sort of trick. So one of the very first things that we can do is we can sort this array, right? So okay, so one thing with LeetCode is that usually you can afford to do up to around like 10 to the 6 and sometimes 10 to the 7 computations. So here essentially we have n is less than or equal to 10 to the 5. So if we revolve our solution around n, right, then if we have an n log n solution, this is at most 10 to the 5 times log base 10 of 10 to the 5, which if I move this 5 over on here, log base 10 of 10 is equal to 1, so this becomes 5 times 10 to the 5, which is less than 10 to the 5 times 10, because 5 is less than 10, which is equal to 10 to the 6. So this is what I mean by like we're able to do n log n solution if we want. So you know what, it might help us in this problem. We might as well do something like array.sort, right? Another thing I noticed is, okay, inside of these examples, it might be that they have that they might just have convenient test cases, but it's like if you look at the pairs here, it's like like 1 9 and then 2 8, which is literally like this plus 1, this minus 1, this plus 1, this minus 1, this plus 1, this minus 1, right? Well, it's like the discrepancy. Okay. ooh, maybe that's one thing we can notice, right? So these numbers, they're like almost like up to k apart, right? Where it's like, or, okay, let me think about this, right? No, if you had something like 0 and 10, that's still divisible by k. Okay, I'm not onto something here. I'm trying to think. So there's clearly some trick that we're gonna have to think of here, right? In something like this, the 10 is at the end, but the 10 goes with the 5. So one thing that's obvious is that we need, well, okay, first of all, like obviously the brute force solution doesn't work, so it's like we might as well not even try. Like 10 to the 5 squared is like 10 to the 10, which like no way in the universe, you'll have to wait till doomsday before, well, okay, LeetCode will not support a solution that will iterate 10 to the 10 times, so we might as well not even try. Okay, I'm trying to think. So it's like, obviously, it's like, if you find a pair, like what I'm saying is like, okay, if you find a pair A comma B, right, that is valid, should you lock in that A and B, right? Where it's like, maybe, is there ever a case where it's like you have A comma B comma C comma D, and it's like A and B is valid, but locks solution no longer possible with rest of elements? You know what I mean? Where it's like, if you find one pair, can it quote unquote screw you with everything else, right? So it's like, let's say A worked with both B and C, and it's like D only works with C, right? And so it's like, if you took C away from D, so how would that be the case, right? So A and B, so let's say A is equal to something, right? We'll say K is equal to 5, right? So A is equal to 1, let's say. B is equal to 4. C is equal to 9. And so how would I make D? Actually, no, right? So maybe I am onto something here, where it's like, okay, if D works for C, and C is just B plus a multiple of K, right? So here's like, C is really just 4 plus 5 times 1, right? Which is like K over here. Maybe one thing we could do is modulo. We could also transform this problem, right? Where it's like, ooh, okay. I'm starting to get ideas, right? Where it's like, one thing we could do is, what if we parse the entire array and get its modulo result with K, right? Where it's like, if you have 10 and 5, that becomes 0 and 0, right? So that doesn't sum to K anymore. If you do 1 modulo 5, actually, okay, so zeros. Ooh, wait, I'm starting to like this idea. Okay, I'm starting to like this idea. Where okay, so what if you modulo everything? So zeros, maybe they just all work together, right? Where it's like, if you get a 0, that was a multiple of K. So the only thing you can add to a multiple of K in order to get a multiple of K is another multiple of K, right? So it's like, every number is going to be of the form A plus B times K, where A comma B are natural numbers, right? Where A and B are integers. For all I, for some numbers A comma B. Since the B part doesn't matter, the only unique values that remain are for 0 less than or equal to A less than K, right? So if I'm modulo, okay, so maybe I can do something like this, right? For I in range length of R of I modulo equal to k. R.sort. Let's print an array and return, what do we return, right? Let's return false no matter what. Okay, I'm getting onto something here. I'm getting onto something. Okay, so here's like 0, 0. So it's like zeros we can pair together. Ones we need to pair together. Ooh. Oh, wait, I think I might have been able to solve it. So essentially, you can count. So, okay. We've modulated these results. We know that the zeros belong together. Then it's like, okay, a 1 must belong with a 4, right? So it's like, you essentially want to get all the counts down to 1, right? So it's like, okay, for zeros, the case is special, right? So we got to think of the zeros case as a separate entity. Actually, we can even just ignore zeros. No. You cannot ignore zeros, right? Because if you have like 10 and just 10 and not 5, then you did not have a pair, right? And so it's like, okay, you got to make sure you have an even number of zeros. If you don't have, you don't have to have an even number of ones, right? If you can have an odd number of ones, so just a single 1 and then a single 4, and that's fine. Okay. I think we don't even need to do a sorting here, right? What we need to do is we have a dictionary here, R of I modulo equal to k. Instead, what we're going to say is d of R of I modulo k itself as a value. We can even call this like what, our base or something? Okay. We take this value and we plus or equal 1 it, right? So we can do plus or equal 1. Let's say this is a default dict of int for now, or even we can just say is equal to, comma 0, d dot get this plus 1, right? So it's essentially, we want to track the frequencies of these things. Now print d, right? So now here's the thing. If Okay, I have a solution in mind. Okay. I'm just gonna code this up. Okay, if first of all, we're gonna check zeros. First step, check zeros, i.e. numbers who are direct multiples of k. If d of 0 modulo 2, this should be even, right? So if it's not equal to 0, then return false, right? Otherwise, delete d of 0. And now we move on. For each number, say we know the keys in D represent the value of A where dictated by number in R for each index I in R, where R of I is equal to A plus B times K for some integer, non-negative integers A comma B. A and B. Okay, so now, as you can imagine, we want the sum of two. We want to match each key in D with another key in D if available, such that each key, key 1 in D, with another key, key 2 in D, such that key 1 plus key 2 is equal to K. In other words, in a spirit similar to a problem like 2-sum, given a key 1, want to find key 2 such that key 2 is equal to K minus key 1. Oh, whoops. Why is my recorder not recording? Let me just file new movie recording. View float on top. Okay, that's my bad. Sorry, I don't know why I was frozen there and so on. That's completely my bad right there. At least I hope that the actual recording is not corrupted. Otherwise, that would make me feel very, very sad. But okay, so sorry that my face was a little bit frozen there. I didn't realize. I was just looking at my typing here. In other words, in a spirit similar to a problem like 2-sum, given a key 1, want to find a key 2. Given key 1, I'll just simplify this here. Key 1. Whoops, no, that is not what I want to do. I didn't want to. D.get 0, otherwise we'll return true by default. If 0 in D, and there we go. Obviously, so this only didn't work with the zeros, right? Because 0 plus 0 will not equal to like a k that's equal to 5. So that's why we do the zeros case first. Okay, so now we want to find key 2 such that key 2 is equal to 1. Key 2 is available if and only if D of key 2's value in D is greater than 0. So now we're going to say we could do something like, you know, okay, because the point is I'm going to modify the dictionary, right? I could also, you know, okay, I could also put them into an array, like a stack or so on, or it's like, or like a set of like things that have been cleared. So it's like, okay, keys is equal to set of d.keys, and I make a set so that way I can do O of 1 removals, right? Then for key and keys, well, D of key is greater than 0. Actually, we don't need to iterate, right? So it's like if my 1, if the value is 5, that means I have 5 numbers such that their values were 1 plus some multiple of k, right? So we need 4s, right? That's what we need. And so we need to make sure that they match the same ones, right? For key in D, right? So I gotta make sure, right? Scene is equal to this. I really wish I would go in order, right? So okay, so the point is if I do something like 1 and 4, right? If I do k minus 1 and k minus 4, actually that the math works out perfect, right? Actually, yeah, for key in D, if wanted key val is equal to D of key. Wanted val key 2 is equal to k minus key. First of all, assert that key 2 it's fine. It's because they're modular anyway, so I don't have to assert that. Key, I gotta think. Wanted. Okay, if d of key doesn't equal d of key minus k minus key, return false. Right, so I think I can do something like this. Otherwise, return true. So does something like this work? Key error 0. Okay. If 0 in D, there we go. Key error 9. So here we're going to do print D, K, and R. Okay, so K is equal to 10. So 1, 2, 3, 4, 5, 6. Okay, so here I have 10 minus 1 is 9. Okay. These are all going to be modulo K, right? So they can never be... these are frequencies, right? Right. Otherwise, I can always do something like -1, but I think something like this works. Okay, there we go. Bada bing, bada boom. Let's submit this. Okay, very nice. Okay, there we go. I knew there was some kind of trick. All right. I'm glad we were able to solve this nice and efficiently. Let's put this away. Yeah, we can keep that comment. For key and D and so on, we really only need to iterate over half the keys, but, or at least, you know, like that way there's the pairs and so on. We can even do something like, instead of for key and D, get key, comma, 0. This starts to get a little messy, right? Okay, first of all, does something like this even work? I just want to check. Okay. For I in range 1 all the way up to k divided by 2. I want to see if something like this works, but it might be a bit more inefficient. Actually, yeah, let's just call this key. So this works. But then it's like we check every single value, right? Okay, so this might be a lot slower. Oh yeah, we need included itself maybe. Right, okay. So it's like, yeah, if the keys are not there and so on, it's just like, yeah, it's whatever keys are in D, then yeah, okay. This is just a little bit of a bummer, but it's all right. Okay. Okay, we can remove some of the code there. Wow, okay, this is a very nice, short, and succinct solution. Okay, I'm kind of happy about it. Okay, it seems like people do this a lot faster though. Okay, does that mean there's a lot faster way of doing this? Okay, I'm at 64%, so I'm past this peak. That's very interesting. So people, oh, you know what this probably is? People probably like this. I've seen this before. It was like a LeetCode problem used to have way less tests, and so people ran it faster and so on, because it's kind of weird like how monotonic it is here and so on. Okay, so that makes sense. So this is good. I beat 64%. Very nice. Bada bing, bada boom. Very excellent solution. And okay, sweet. Nice and short one for today's daily. So as always, in all my videos, I do a quick recap of how I was able to solve the problem at the very end of the problem. So one of the things that I realized essentially is, okay, we want the sum of these pairs, right? First of all, we want to find n over 2 pairs such that each of the sum of the pairs is divisible by k. It's very suspicious that they don't ask is equal to k. They ask is divisible by k, right? And so if you think of any two numbers, num1 and num2, right? Well, we can comment this out, right? I even will put it on different lines. This is essentially going to be equal to some like a1 plus k times b1, kind of like in complex numbers, right? Where like a1 and b1 are integers. And same thing for num2, right? So a2 plus k times b2, right? So something like this. a2 comma b2 are integers, right? So for any two numbers, they're essentially going to be non-negative integers, right? Non-negative integers, right? And it's like each number, they might be negative, I suppose, and so on. I guess I didn't have to worry about that. Okay, but the point is like we can write it inside of this form, right? Even if they're negative integers, right? So we'll just put it like this way. It doesn't even matter at the end of the day. Okay, so essentially we can have each number is essentially depicted like this, right? So it's like some offset. So it's k times a number, even if that number is 0, right? So b1 could totally be 0, right? And or b2 could totally be 0, right? And so it's just k times something plus a little bit of an offset, right? So you can essentially think of any number as just a multiple of k plus some little offset that is and 0 less than or equal to a1 less than k, right? Or if I do plus 0, then it becomes a multiple, right? So a1 is in this range. Actually, it can be 0 if it's a direct multiple of k, right? And 0 less than or equal to a2 less than k, right? So essentially every single number can be written in this form. So now one thing that we realize is like, okay, what if for each number, I kind of got rid of this part, right? If I modulo the number by k, so it's like, if I know that num1 plus num2, they are divisible by k, what does this give me, right? So then that means that num1 plus num2 is divisible by k, right? Which logically means that a1 plus k times b1 plus a2 plus k times b2 is divisible by k, which is logically equivalent to a1 plus a2 plus k times b1 plus, k times b1 plus k times b2, right? And here I'll even put this in parentheses, so I essentially take k out of the equation. Here I take k out of the equation. Is divisible by k. Right, there we go. Logically equivalent to a1 plus a2 plus k times, here I'll separate these, b1 plus b2 is divisible by k. All right, sorry, it's just, I'm writing a lot. And then again, you'll notice this is just k times a value, right? This is by default divisible by k, which means the rest of the sum must also be divisible by k, right? And so it's like, okay, which logically means that a1 plus a2, quote unquote, is divisible by k. So really what this shows is that between the num1 and num2 parts, we really just care about this a1 and a2 number, right? That's all that we essentially care about. And another nice property is that a1 and a2 are going to be between 0 and k like not inclusive, right? And another thing I do in this problem that I'll explain later is I hard code the 0 case and so on, so that way I can think of only numbers that are greater than 0 and smaller than k, right? But essentially the very first thing that you have to realize is that essentially if two numbers which are of this form, which every number is of this form, happen to have a sum that is divisible by k, then it must mean that the a1 and a2 parts of those two numbers summed together is also divisible by k, right? Which makes sense. Like this is a multiple of k and some offset away from k, right? And then this is divisible by k and some offset away from k, right? These two numbers are divisible by k, so it better be that the sum of these two numbers add up to an offset that is divisible by k as well, right? So that's essentially the idea. So the very first thing that I do is what I realize essentially is that these two numbers need to complement each other, right? So let's say that, for example, a1, that k is equal to 5, right? And then a1 is equal to 1. Then what do I need a2 to be, right? Well, okay, let's not think of negative numbers, but technically something like -6 here works, right? Because it's like 1 minus 6 equals -5, which is divisible by 5. So that's why my solution works as well, and so on. But let's think in terms of positive integers just to make our life easier here. Essentially, it's like a2 is equal to question mark. What does a2 need to equal? Well, okay, we need the sum of a1 and a2 to be divisible by k, right? And again, we've restricted the values that a1 and a2 could be to be between 0 and k, right? So if that is the case, the only single possible value that a2 could be such that the sum of a1 and a2 is divisible by k will be the value of a1 and, of a2 such that the sum of a1 and a2 is not only divisible by k, but exactly equal to k, again, because we essentially have these constraints backset in place, right? Now, the only caveat is that if I set like a1 is equal to 0, one thing you can definitely notice already is that, you know, if this is 0, it doesn't matter how big this is. This is at most k minus 1. 0 plus k minus 1 is less than k and so on. So you'll never be able to sum up to k. And so this was just something I was realizing early on. Essentially, what does it mean if the number is 0? That means that this a1 or this a2, it was a value of 0, which means that this was the value of num1 because 0 plus anything is just that anything, which means that num1 or num2 was already divisible by k, right? So essentially, if you have a 0, that means that like, okay, I had a number that was already divisible by k, right? And essentially I just say like, okay, the number of such zeros, let's make sure they're even, right? Because like, if a number is divisible by k, the only other number you can add to that so that it's still divisible by k is another number that's divisible by k, right? If this a2 happens to be non-zero, then this plus this a2, which is non-zero and less than k, will not be valid, right? So the only number you can add to a number that's divisible by k is another number that's divisible by k if you want their sum to be also divisible by k, right? So we just handle the zeros case, and in the zeros case, we just say like, okay, the number of numbers that are divisible by k better be even, right? Because it's like, again, if a number is divisible by k, the only other number that can be added to it so that it's still valid is another number that's divisible by k. So all the pairs of numbers that are divisible by k must be together, right? So if the number of zeros that I have, which represent numbers that are divisible by k, is even, then that means I can create pairs between them and bada bing, bada boom, right? If it is odd, that means like for example, if I have 3 numbers, then I can create a pair between the first 2, but then I have 1 remaining that has no other number in the array that it can form a pair with and have their sum be divisible by k. So that's why I make this check for like, if 0 is in D, right? Essentially just say like, hey, okay, is the number of zeros divisible by 2? And if not, then return false, right? Because that means there will be exactly one number who's divisible by k and no other number that is divisible by k for it to match with if I locked in all the other ones, right? So that's essentially why I return false. Otherwise, all the numbers that I have left with is essentially, so let's make this easier. At this point, I now have the added benefit that 0 less than a1, comma a2 less than k, i.e. no longer equal to 0. a2 doesn't equal 0, right? So now these numbers don't equal 0, right? So if I have 2 numbers that are less than k, and I want their sum to be equal to k, or a number divisible by k, right? So a1, comma a2 are less than k, and want their sum to be divisible by k, which is only possible then so A1 plus A2, so so essentially we have this, which implies that 1 is less than or equal to A1 comma A2 less than or equal to K minus 1, which implies that the sum of A1 plus A2 is less than or equal to 2 times this, so 2 times K minus 1, K minus 1, 2 times 1, or 1 plus 1 to K minus 1 plus K minus 1 to 2 less than or equal to A1, and what's the value of K? K is at least 1, right? A2 2K minus 2. Right? So, okay, maybe I'm not doing a great job of explaining this, but essentially, all I'm trying to point is this. Let's make this a bit more simple. Essentially, if I have A1 comma A2, right, and I have K is equal to 5, right, and I know my A1 is equal to 1, essentially all I'm saying now is that since these are less than K, if I'm going to have a sum of these two numbers such that they are a multiple of K, the only way that's going to happen is if their sum is legit directly equal to K, right? So it's like, because again, these are the ways that it's defined. So it's like you get rid of whatever multiple of K the number 1 was initially as, and whatever multiple of K that number 2 was initially as. So essentially it's like, if A1 is equal to 1 and K is equal to 5, then you need the sum you need A2 to be whatever remaining sum A1 needs in order to be equal to K, right? So the point like that I was trying to show a bit mathematically, but I'm realizing is a little bit convoluted and complicated to show and not very effective explaining. But essentially all I'm trying to say is like, okay, this A1 and A2, if their sum is going to be divisible by K, the only way that's ever going to happen is if they are directly equal to K, not just some random multiple of K, right? And so essentially all I can check is basically, I think it'll be a bit easier if here I just take the time to print my dictionary D, because this will just make a lot more sense. So essentially my dictionary D here, right? These maps keys, so these are like A1 and A2 values, right? So each number, I essentially will assign it to a new number between 0 and K not inclusive, right? So the K not inclusive part makes sense. As for the 0 not inclusive part, it'll make sense when you realize that I already took care of the 0K. So this I already explained. Now every other number in K, so essentially these keys are going to represent numbers that are between 1 and K minus 1 inclusive, right? So in this case, K is equal to 5, so it's expected to see you'll have 1, 2, 3, and 4, right? And it could be also that a key doesn't exist, in which case it just has to have an effective key with a value of 0, right? There are 0 numbers that essentially had that key value, right? And so essentially all I'm saying is like, okay, for 1, that means that my A1 was a value of 1. So I need an A2 of 4 in order to match it, right? Because I need that K is equal to 5, right? And I have this number is equal to 1. I need a number who was 4 away from a multiple of K, right? Because if I have this number that's 1 away from a multiple of K, and then another number that's 4 away from a multiple of K, then when I add them together, I'll have a number in total that's the two multiple of K's together, which forms another multiple of K, plus these two guys' sum, which is now equal to K, and therefore the whole number happens to be a multiple of K, right? And so the way that I do this is very simple. It's like, okay, here for 1, I have 2 such numbers that are this way, right? And for 1, I need to match it with a 4, right? So how many numbers do I have of 4? If I don't have exactly the number of numbers that I have in 1, right? So for each of these numbers, essentially for each of these ones, the only thing it can match with is another 4, right? Because again, these are the A1 and A2 values. These A1 and A2 values, since they are less than K, if you want their sum to be a multiple of K, it better darn be exactly equal to K, or at least, it depends if K is very small. So at least a multiple of well, exactly equal to K, right? Because these numbers at most, right? If you could take 4 and 3 and so on, okay. But my idea is essentially like, okay, let's make them exactly equal to k, right? So if I have this 1 and I have this 4 here and I take them together, that's exactly equal to k. And so if I have these a1 and a2s together sum up to k, then the whole thing becomes a multiple of k, right? So a1 plus a2 is divisible by k times b1 is definitely divisible by k, and k times b2 is definitely divisible by k as well. And so I guess I'm kind of having like a hard time explaining my logic behind this, but again, it's just like, I know there's this a1 value with a value of 1, I need to match it with a 4. How many such numbers with an a1 value of 1 do I have? I have 2 such numbers. Each of those numbers must be matched with an a2 with a value of 4. So if I do not exactly match the number of numbers with a value of a2 of 4, then I cannot return the solution. In this case, I have 2 such numbers that are off by 1 from k, and I have as well 2 such numbers that are off by 4 from k. Therefore, for each of those, I will have been able to create a valid pair, and so that's not a problem, right? Then I check for 2 here, right? So these are numbers that are off from a multiple of k by a value of 2, right? So I need to match these numbers with numbers that are an offset away from a multiple of k of k minus 2, which is 5 minus 2 is equal to 3, right? So in this case, it's like I have 2 such numbers, and then I have 2 such numbers that are 3 away from k, so therefore I can make a matching for each of them. And then when I go back to 3, I do like, okay, I'm off by k from k by 3, so I need to do k minus 3 as my remaining offset to reach another new multiple of k, when k is equal to 5, so 5 minus 3 is equal to 2, and so it's like, okay, from 3 I have 2 such numbers, from 2 I have 2 such numbers, okay, therefore there's a match, right? So the point is like, I check exactly, so like, for 1s, they need 4s, right? So it's like, for each of this, there better be a 4 to be able to match it exactly, right? To be able to form those pairs, right? So it's like, essentially think of these as like keys, and like each of these keys like can only make pairs. So like for 1s, these guys can only make pairs with keys of 4, right? Because again, it's like the keys themselves need to sum up to a multiple of k. So an easy way is to make them sum up to exactly k. And so if you have these keys and you want to make sure, and you know that they can only match with another specific key, then you need to make sure like, hey, okay, they better have the exact same number of total number of values, right? So like this represents a number of numbers with this key. They better match the exact number of numbers with this key, otherwise we return false, right? So here is just like for key and d, if the value of that key is not equal to k minus key, right? So for something like 1, 5 minus 1 is equal to 4, so that's why I look at this 4, and I do a default value of 0 because none of these can have a value of 0. If they're not equal, right, not exactly equal, so that I can make a pair for each single one of those, then I return false, otherwise I return true. So okay, I realize my explanation might not have been that great. It made a lot of sense in my head as I was coding it, because again, it's like I think like, okay, the minimum value that I'll have here is 1. The maximum value that I'll have here is k minus 1, right? So it's like the point is that like I have 1, 2, 3, come on, dot, 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 all the way up to k minus 2, k minus 1, and there we go, right? Or like k minus 3 and so on. And so it's like, I was like, okay, let's pair the 1s with the k minus 1s, right? Let's pair the 2s with the k minus 2s. Let's pair the 3s with the k minus 3s, right? So these are essentially the numbers that I have. So therefore it's like, I'm going to, so that way, like these guys, they sum up to k, right? These guys, they sum up to k, right? These guys, they sum up to k. And we know that these represent the a1 and a2 values. So it doesn't matter what multiple of k these two values are, the whole resulting sum will still be divisible by k, again, by this little formula proof right over here, right? So that's essentially my idea here, right? So it's like, yeah. Okay, so that's why I mashed them in this order. So again, we can resubmit one more time. Yeah, if that explanation did not make too much sense, just let me know in the comments and I can try to clarify it a little bit better. I know it took a while to explain it as well and so on. And yeah, I'm very sorry if that explanation doesn't make sense. I hope that it does. It's just, again, like the idea to this problem essentially is just like take all the numbers and modulo it by k so that you can tell what offset away it is from k. And then you need to make sure that like, okay, for each essentially offset that I have, I need to match it with the appropriate remaining offset so that the sum of the two offsets happen to be divisible by k, right? And so obviously 0 plus 0 is divisible by k. Otherwise, if I have a number that's between 1 and k, then I need to make sure, like, okay, if I have 1, I need to get the k minus 1, right? If I have the number 2, I need to make sure that I get k minus 2. If I have a number j, I need to make sure that I match it with k minus j, right? So that's essentially the idea. And so that's why I do this little loop over here where it's like for every key, I match it with k minus key, because key plus k minus key will be equal to literally k. So key plus k minus key is equal to k. And therefore, it's like, that's why I'm checking those pairs. So sorry about that if that explanation doesn't make too much sense. So again, if it doesn't make sense, just let me know down in the comments, and I'll try to clarify it a little bit more. But otherwise, yeah. So I hope it did make some sense. Otherwise, but that's pretty much it for this video. If you did find it useful or enjoyable, I would highly appreciate if you left a like or a comment, and I will get right on with my board game night. So I'll catch you in the next one, and until then, ciao ciao, my friend. Bye bye.